same page at least where we're at the student. We started off with the first topic looking at slope fields and just this idea of the differential equation and different ways we can analyze it. We looked like how to make a slope field, how to read a slope field, how to approximate it with a tangent line and Euler's method, and then just using the idea that these differential equations really are just representing the derivative in many ways. Today we are going to look at solving a certain type of differential equation. And these are going to be the only ones that we have to know how to solve, and those are going to be what we call separable differential equations. These do not include all differential equations. There are lots of different types of differential equations and lots of different complexities, including ones that can only be solved with like computer programs. We only need to know the most basic type, which is going to be called a separable differential equation. So before we look at a separable differential equation, let's talk about stuff that we should already know how to do. We know that solving a differential equation is basically going to involve a lot of integrals. So I will say any integration rule that we have learned can show up in these problems. So anything from like trig, power rule, exponential rules, inverse trig rules, to things like even partial fractions, integration by parts, like any integration method we have learned can kind of show up in these problems. I chose just some of the most basic ones just because, and then we'll kind of look at these in the context of separable differential equations. So I do have things separated, like you kind of get from its name, separable differential equations, that we will be doing some separation in many ways. So in like that first column, I have everything in terms of dx, and then that second column is everything in terms of dy. We know it's not even worth discussing. The integral of x dx is just 1/2 of x squared plus c. Same thing with the integral of y with respect to dy is just 1/2 y squared with plus c, plus c. What about that second row? What do you think the integral of dx is going to be? Just x. So you can kind of imagine there's like a 1 there. The integral of 1 dx would just be x plus c. So the integral of dy would just be y plus c. And I try to pick some common rules that we often see with these problems. We will often see trig, natural log, inverse trig, and exponential. Those are like the main ones that we will see. Natural log, definitely don't forget the absolute value there. So the integral of 1 over x dx is going to be the natural log of the absolute value of c. What about that second one and that third row? What rule is that one going to be? Arc sine. So the difference of the degrees is more than 1. This one is 9 minus y squared, so that's going to be an arc sine. Your a value is 3. Arc sine doesn't have a 1 over an a in front, so this would just become the arc sine of y over 3 plus c. And then I have the integral of tangent. Again, all those trig rules we've learned. If you have forgotten these rules, you definitely make sure you review them for this unit. Integral of tangent is a rule we have. Tangent is sine over cosine, and its integral is the negative natural log of the absolute value of cosine. And then we have the integral of e to the y. Well, what's going to be the integral of e to the y? Just e to the y plus c. So again, can't emphasize enough, if you do need to go back and review your integration rules, like please do that, because you do need to know all of your rules in order to do this process correctly. So let's go ahead and define separable differential equations. A separable differential equation is going to be an equation, a differential equation to be clear, but it's an equation that can be written in a certain form. And that form is going to be one where we basically separate anything in terms of y on one side and anything in terms of x on the other. So we'll often write it like g of y dy is equal to f of x dx. And not to overcomplicate that or anything, but basically you're going to have all of the y's on one side and then all of the x's on the other side. Those are going to be the only types of equations you have to know how to solve in this class. Again, there are other types of differential equations, but those are going to be the ones that we focus on in Calculus BC. So an example, this one is an example of a differential equation. Right now, it's written as dy dx is equal to 2x over 5y squared. I know this one is separable because I can do correct algebra to get all the x's on one side and all the y's on the other. What's the easiest way to do that? You can simply just, in this one, like cross multiply, and you end up with 5y squared dy, and that's equal to 2x dx. So I got anything with a y on one side, anything with an x on the other. One thing you will notice a lot in this topic is there's often like different paths you can take and still end up with the same right answer. For example, that's how I would probably separate the variables. The other way to do it, some people might just multiply by the y squared. And so I have like this 2x over 5 and then multiply both sides by the dx. Those two answers, even though those look different, algebraically they are equivalent and your final answer would be the same. So do get kind of used to the fact that, like, especially when you're like doing the homework and checking your answers, that there often is more than one path you can take to get to the right answer as long as you're following proper algebra. So go ahead for me before we get to solving. Here are 3 examples, and I'll scroll so you get to the third one. But I want you to first determine, would these be considered a separable differential equation? If they are, then go ahead and like separate the variables, and if not, then clearly you can't separate them. But go ahead and try those 3 for me. Again, you're first determining if they are separable, and then you do want to make sure that you can separate them. On the AP exam, you probably will have a differential equations question on free response. And often how it's graded, at least from my experience, is that first step requires separating the variables. If you cannot separate them, or if you separate them incorrectly, that is the line where the AP grader will stop grading your question. I'm going to do the same thing for your quizzes and your tests. So like if you're unable to do the algebra to separate them, which you can't do the algebra, you're probably definitely in the wrong class. But if you can't do that algebra, then that's where I stop grading and just move on to the next question. But 2 of these are separable and 1 of them is not. So you can figure out which 2 are, separate them, and then which one is not, and then of course leave it as is. That first one, would it be considered a separable differential equation?
Yeah.
Yes. So we can. Typically, we just have a bunch of multiplication division. You can eventually separate them. So you might have started off by cross multiplying, and if you cross multiply, then at that point they aren't separated. But then you could just like divide twice or kind of in a single step and then separate it. So like separating these answers, that will be okay. You can have like 1 over 4y dy is equal to 1 over 9x dx. That's probably how I would choose to separate it, but other answers that would be equivalent and correct would be like 1 over y dy is equal to 4 over 9x dx. That is the same and equivalent. Or you could have it as 9 over 4y dy is equal to 1 over x dx. All of those will give you the same answer. Again, this first one tends to be my preference. Maybe the second one, probably not the third, at least for me. That second one, separable or not separable? It's not. And again, you would want to make sure you kind of follow the algebra. So that is x plus y. So if you were to multiply both sides by dx, you would get dy is equal to this x plus y dx. Well, that dx is technically distributing to both of those. And then you just kind of get stuck, and you can't ever get that y by itself, because you would have like y is equal to x dx, which is fine. But then you have like this plus y times dx, and that's kind of the issue. This one is not separable. So that is one that we would not solve by hand. We can still do things with it. Like I could ask you to find like a tangent line. I could ask you to draw a slope field. I could ask you to find the second derivative of it. So you could still analyze it, but you couldn't solve it. This would be a good question for me to do like an Euler's method on, because you could only approximate it and not solve it. Last one, separable or not? Yes, I guess the third one we know it is. Acceptable ways, 1 over cosine of y dy is equal to the sine of x dx. That's definitely correct. I know that when I'm solving a differential equation, we're often going to integrate it. So what's probably the better way to rewrite it instead of 1 over cosine? Secant. And I would rewrite as secant because we do have a rule to integrate secant. But again, we've separated the variables, and that's always going to be the first step. So let's look at a question. And here is the first question that I want to do. We are going to have to spend some time at looking at the question, the way it's formatted, because it will not explicitly always tell you how much work you need to do. And you are going to rely on the question to tell you how much work to do. So when I look at this one, it just says to find the general solution to this differential equation. So what that tells me is I'm first going to have to separate and then integrate. It doesn't give me a particular solution, so I'm not going to have to plug in like the initial condition. It also doesn't tell me that I need to solve for y, so I just need to separate it and then integrate it. So this one pretty easy to separate, multiplying both sides by 3y squared, and then multiplying both sides by dx. We then separated our variables. This is why we separate it, so I have all the y's on one side, all the x's on the other. Now I can integrate both sides. It's still an equation. What I do to one side, I have to do to the other side. And then we can just go ahead and integrate it. So the integral of 3y squared is just y cubed plus a constant. The integral of 4x plus 3, that will be 2x squared plus 3 plus a constant. I don't want to use c again, so I'm going to call this first one c1 and that second one c2. So that is what you would get if you integrate it. But let's kind of simplify it some. If I just want to deal with one constant, so I'm going to subtract the c1 from both sides. So I have y cubed is equal to 2x squared plus 3x. Sorry, I forgot that off. Plus 3x. C2 is a constant. C1 is a constant. Well, what's an unknown constant minus another unknown constant? Just another unknown constant. And I'm going to call that one the plus c. I show you that mainly to say this now. I will always jump straight to that step when I integrate. So we won't have to have those 2 plus c's. It just makes it overly complicated. So we only need 1 plus c. I tend to always put my plus c on the side with the x's. Technically, it wouldn't matter which one you do. You do just want to make sure that when you do pick a side for your plus c, you're at least consistent when solving it, because not all c's will be the same. So like, just be consistent with whatever you decide to do. I like having mine on the side with the x's, because typically you would solve for the y, and so it would just make it a little bit easier. This one didn't ask you to do anything else, so that would be your final answer. Questions on that problem? All right, let's look at the second question. This one says find the general solution y is equal to f of x of this differential equation. How's that instruction a little bit different from the one that we just did? It's not a big difference. Let's compare. So find the general solution, y is equal to f of x of this differential equation. The one we just did said, find the general solution of this differential equation. What's the main difference? The y equals f of x. And this is super important, and it's not like an obvious thing, I think, to most students when you're first looking at it. That statement, y equals f of x, is telling you actually to do a whole lot. So this is telling you your final answer needs to be solved for y. And your final answer must be a function. And that's why it's using the function notation. So it's basically telling you to solve it for y, so that y is a function of x. And we'll kind of talk about how to make sure we satisfy both of those. So again, it does tell us to find the general solution. Instead of writing y prime, when we do differential equations, it's going to be easier to write it as dy dx, so you actually have something to separate. First step is to always separate, and then you can integrate. So I'm going to multiply by 6y squared, and that will be dy, and that's equal to 1 times dx. Now technically, you could have also written it as y squared dy is equal to 1/6 dx. Like that would still be separating the variable, but I'm going to avoid a fraction if I can. It just makes my life a little bit easier. So I've separated. Now I'm going to go ahead and integrate it. So that's going to become y cubed, 6 divided by 3 is 2, is equal to, the integral of 1 is x. And again, I only need 1 plus c. I often choose to pick mine and put it on the side with the x's. That is the general solution, but it's not the one in the form of y equals. So we do just want to get it into the form of y equals. So I'm going to go ahead and divide both sides by 2. And so I have x plus c over 2. And then take the cube root of both sides. So I have y is equal to the cube root of x plus c over 2. Now here's another thing where we need to kind of pause and talk about your answer. What again is c representing in this problem? It's a constant. More specifically, it's an unknown constant. So maybe this is like a multiple choice question. There is a possibility that this is not an answer listed. So we want to talk about how we can find equivalent answers that would be the same. Well, if I have the cubed root of all that, one possible way would be the cubed root of, if I'm dividing by 2, that's like x divided by 2 plus c over 2. Again, just using math algebra. If c is a constant, what is c over 2 going to be? What's a constant divided by 2? An unknown constant divided by 2 is just another constant, right? We don't know. It's just another constant, right? Like we have a constant divided by 2. It's just another constant. So this one could also be written as the cube root of x over 2. I already used c, so I'm not going to use it again, but I might say something like c divided by 2 is, I don't know, I'll pick another letter of the alphabet. K is a common one we see on the AP exam. This answer is equivalent to that answer. Why is it equivalent is because we never solved for c, so it didn't really matter what it represented. Now, I do often see students try to rewrite it and they do it incorrectly. So I do want to show you a wrong answer I often see. So this one is a wrong answer, just to make sure you don't do it. And a wrong answer I see is people write the cube root of x over 2, and they'll put like their added constant on the outside. That doesn't follow math and algebra because you can't take a radical or a root over a plus or minus sign. So like that constant is not ending up on the outside of that radical. It's kind of also changing the shift of it. Like this won't be a slope field with a bunch of horizontal transformations, what the answer should be. The wrong one is on the outside, so it's like a bunch of vertical transformations. So you just want to be careful in that when you're doing these problems, like just do proper algebra and you'll be good. Let's keep on trying some examples. Next one. Find the particular solution y is equal to f of x of this differential equation given that f of 0 is equal to -5. Hold on, did I solve that one? Yeah. So let's talk about this one. Again, the question will tell you how much work you have to do. We see the particular solution here, so that tells you we are going to have to solve for c. So that's your clue right there. We are going to have to solve for the constant that we have. This part right here, y equals f of x, tells us that our final answer is going to have to be solved for y, and it is going to have to be a function. And a function. And so let's go ahead and try it. What's going to be your first step to do always? Separate. And it doesn't matter how you separate it as long as you do it algebraically correctly. I'm going to go ahead and just cross multiply. So I have 3y dy is equal to e to the 4x dx. After you separate, what's next? Integrate. So I have 3y, that will become 3/2 of y squared is equal to. What rule in addition to the exponential rule will I need to make sure I do when integrating e to the 4x? U substitution. So this is e to the 4x. So I do know that u would be 4x, u prime would be 4, dx is du over u prime. So I would have 1/4 e to the 4x plus c. Some things I want to talk about when the AP exam is grading it. So a differential equation problem, if you're solving it, one like this that goes all the way down, it's usually worth 6 points out of 9 points on a first response question. If you don't separate your variables, they stop grading at that point. But that, if you do separate it, then that's like one easy free point that you get. And you always want to show where you separated your variables. The next line is usually worth 2 points. You get a point for the antiderivative on each side, as long as you have a plus c in the problem. Here's another time, and this happened a lot when I was grading AP exams in summer. Say students separated and they integrated, but they left off that plus c. You just get 1 point, and the AP reader moves on to the next question. They don't even look at what else you did, because if you can't remember to put a plus c, then clearly you can't solve for it, you can't do anything else. So like that plus c has to be there. And then here's where I want to talk about where you can make a decision when plugging in your initial condition. You do have two choices. Your first choice is you can plug in the initial condition after integrating. And that's your first option. The second option is to solve for y first, then plug in the initial condition. I have a preference of doing it the first way. I just find personally for me, it tends to be like the math just works out a little bit nicer when I plug in my initial condition first. That being said, I have plenty of students who like solving for y first just because that's what they're used to doing, and then plugging in your initial condition. Either way, as long as you're doing like proper algebra, you're going to get to the same answer. But again, my preference personally for me is I like plugging in my initial condition first. So it does tell me that this is going through f of 0 is equal to -5. So I have 3/2 of -5 squared is equal to 1/4 e to the 4 times 0 plus c. Let's see, -5 squared is 25, 25 times 3, that's 75/2 is equal to 1/4, e to the 0th is 1, plus c. So c would be equal to, what's that, 150/4 minus 1/4, which is 149/4. Again, the other option, can I start that problem? Solve for y first, then plug in the initial condition. But I like kind of getting my initial condition now. So then I can go ahead and rewrite my equation. So now that I know what c is, I have 3/2 y squared is equal to 1/4 e to the 4x plus the 149 to the 4th. Can I leave my answer like that? I cannot leave my answer like that because it told me I had to solve it for y. So now I just want to be careful, like the calculus is done, I just need to do the algebra now. So y squared is equal to 2/3 times all this. Could distribute it if I wanted to, but that's not necessary. I take the square root. What do I need to remember I do when I take the square root? Plus or minus. And again, I could distribute that 2/3. It would probably make it a little bit easier, a little simplified, but I don't have to. And then I get to that answer. That answer right there would not earn full credit. What's wrong with that final answer? It's not a function. So let's think about this. This is basically a square root function, right? Like I know there's a lot of other stuff kind of going on. But if we have a plus or minus, you have like the plus and the minus. This fails the vertical line test. It's not a function. So you want to go back to when you did this plus or minus. Again, that literally means plus or minus, not plus and minus. It's either the positive or the negative. Don't make it more complicated than it needs to be to figure out which one it is. Just go back to your initial condition. What was the y in your initial condition? -5. Well, the only way that this y is a negative number, which one are you going to have to pick as your option? The negative. So your final answer would be y is equal to the negative square root of all of that. And again, we did that because the initial condition was less than 0. Do make sure you don't do also bad algebra, like you can't take the square root across plus or minus signs, so you want to leave all that inside the radical. Yes, that's
so would we ever have to like fully evaluate to figure out which sign, because like the inside has a negative in it and the initial negative?
Typically you can just look at the initial condition and pick the plus or the minus.
Okay.
Liam.
Why did it go from 1/4 e to the 4x to 1/4 e to the 2x?
Oh, I don't know why I wrote the 2x there. Thanks. Because that definitely doesn't make sense. Yeah. Thanks. Any other questions on that one? And again, that does show up a lot where we have plus or minus and you're going to have to pick the plus or the minus. I'm going to skip example, no, I am going to do example 4. I'm going to skip example 5, but go ahead and try that one on your own for me. So I have find the particular solution, y equals f of x. So we know that does mean a lot. We have to like separate, integrate, find the initial condition, and then solve it for y equals. If you're stuck on separating this one, I would recommend like factoring out the y first. But go ahead and try this one on your own. And I have one more problem to do after this, and that's where I'm going to stop at today.
You're pretty slow. Yes, it is. That's good. Yes, it is.
And of course I'll explain all what I did with just some reminders. It doesn't matter when you plug in your initial condition, you can plug it in immediately after you integrate, or you can solve for y first. I think this is a good example of why I think I like plugging it in before solving for y, because you have an easier equation and many ways to deal with before solving for y. But it doesn't matter as long as you're kind of consistent. But this one, in order to receive full credit, your final answer has to be in the form of y equals, and it has to be a function. So again, if I'm separating my variable, that's the first thing you have to be able to do. I notice that both of these terms have a y in them, so I can go ahead and factor out that y. And then I can separate. So I'm going to multiply both sides by dx, and then divide both sides by y. So just be careful with your algebra. That does become 1 over y. Integrating 1 over y, that's going to give you the natural log of the absolute value of y, equal to 1/2 x squared plus 2x. And again, we only need to have 1 plus c. My preference is plugging in my initial condition before solving for y. So this becomes the natural log of 1 is equal to 1/2 times 2 squared plus 2 times 2 plus c. Natural log of 1 is what? 0. And so then I have 1/2 times 4, which is 2 plus 8 plus c. So c is equal to, not 8, try that again, 4. So c is equal to -6. Again, if you had possibly like solve for y first and like change your c to a k, you might have a different constant, but just make sure you plug it in at the right time. So then rewriting my equation, plugging in that constant, I have, again, I'm going to kind of combine those answers. The natural log of the absolute value of y is equal to 1/2 of x squared plus 2x minus 6. If this problem did not have the y equals f of x in it, then that would be your final answer. That would be a particular solution of the equation. This one is asking you to solve for y, so when you think algebraically, what do I need to do to both sides to get that y by itself? Base e, so how do we cancel out a natural log? We have to base e both sides. So on that left-hand side, we're just left with the absolute value of y. The e and the natural log cancel each other out. On the other side, this is going to become e, and then all of this other junk is in the exponent. Well, how do we solve the absolute value? Well, to get rid of the absolute value, like we know that when we plug in a positive number in absolute value, it comes out as a positive. If I plug in a negative number in absolute value, it still comes out positive. So when I drop the absolute value, that's the same thing as saying y is equal to plus or minus e to all that junk again. Can't have the plus or minus there because that's not a function. So now I need to kind of use the initial condition to pick which one it is. Looking at the initial condition, the y coordinate is a positive one. So it's plus or minus. Which one am I choosing? I am choosing the positive one. For this one, it would be fine if you just jumped straight to that last line I have and kind of notice that it was going to be the positive one anyways. Because some people also, you could argue, you could drop your absolute value sign at the beginning since your y value is positive already. Yes, sir?
How many times will the problem not give you y for that, right?
You will always have enough information to figure out is it the positive or the minus from the initial condition.
But how many times will it say?
Mr. Brown,
Well, how many times will it not have this?
Yeah,
On the AP exam, they almost always have it as y equals f of x.
okay.
Yes.
so what if you had a negative in front of 1/2, or like, would that not change the whole like positive negative that you're basing it on?
A negative, where am I looking? Just in front of that term?
It could be like any term, right? Like but
Yeah.
like multiply to everything, like e to the negative 1/2 x squared. What if there was something like that? Would that not change the whole
No, because again, I'll just kind of write up here. This is like the what if situation. Like if this had been like e to the negative of all that junk. Is that what I'm hearing?
Yeah.
So like that wouldn't change it because like an exponential in this case is always positive. So like the plus or minus would still be considered the same way.
Okay.
Like e to the negative something is just going to be like the decreasing exponential instead of an increasing one, but it is still always positive.
Mm-hmm. Okay.
And the only time that really shows up is like it shows up a lot for log problems, but those have the absolute value, and it shows up for even roots as well. All the other problems you wouldn't have to really worry about that. Last problem I want to do, so I'm switching up the order. Example 5 I have in 2 parts, mainly to talk about how we can simplify 5 because it does use a lot of exponent and logarithm rules. And I don't want to rush it, and I do want to give you time to start the homework. So I'm just going to finish up class by doing example 6. And that's where I'm going to stop at today, and then we'll just do example 5 tomorrow. But go ahead and try example 6 for me. So this one actually is a little bit less work. I mainly chose this one to talk about all the different equivalent answers you could possibly have. But it says find the general solution, so you're not solving for the constant, but you are solving for y of that differential equation. So go ahead and try that one for me. Main thing again that I chose this one for is to show you all the different possible correct general solutions you could have that would receive full credit, and different ways to kind of write them and things like that. But go ahead and try that one on your own.
Do you have any more batteries or service batteries?
I lied, I don't.
Oh, that's convenient.
I can get some more tomorrow. Here is one, but I don't know if it's dead or not.
It's fine, no, it's fine, I have one at home, because
Just for the next 30 seconds, so I can test it out.
You can have it.
Alright.
So again, to separate this one, I'd probably move that second term over to the other side. I just by habit like getting all my y's on the left-hand side and all the x's on the right-hand side. 2 ways to separate it. I personally would do it the first way I wrote it down, where I just divide both sides by the y squared plus 4 and leave the negative 1 on the other side. Some students just like moving everything over to the other side, and so then the negative would end up on the other side. I'm not going to work it out the way that I have in parentheses, but do realize, like, when we start doing it, if you did it that second way, like, you might have some signs that are, like, opposite, but, like, a negative c is just a constant, like, plus c, so it won't change it ultimately. But I'm going to look at this first way. What rule are we going to need to use to integrate 1 over y squared plus 4? That's an arctangent, so it is an inverse trig. A value is a 2. So integrating this one, I have 1 over the a value. Arctangent of y over the a value is equal to the integral of -1 is negative x plus c. And I just want to go ahead and solve for y, because it does ask me to solve for y. So I'm going to go ahead and multiply both sides by 2. Again, doing proper algebra, so I have negative 2x plus 2c. How do I get rid of that arctangent? I can just rewrite it, take the tangent of both sides. So y over 2 is equal to the tangent of negative 2x plus 2c. And then solving for y, multiply both sides by 2. So I have y is equal to 2 times the tangent of negative 2x plus 2c. That is a correct and allowed answer. Other ways we could rewrite that one. C is a constant, so what's 2 times c? Just another constant. This answer would also be okay. I'll just choose K. An answer that I often see that is incorrect is people write it as y is equal to 2 tangent, and then they'll have like negative 2x, and they'll let that constant just keep hanging out on the outside. That would be wrong, because the way we did this algebra, that constant ended up inside of that tangent function. So again, just follow algebra. And again, if you're comparing the answer that you did, if you did separate yours this way, where you put the negative on the other side, then mainly the only difference is that sign in front of the constant would have been the opposite sign. But again, like negative 2c is just a constant, like positive 2c is as well. Any questions on what we did with separable differential equations today? All right. So to close out, what I want to talk about again, have to be able to separate, have to be able to integrate. Again, there's usually a differential equation for response every year on the AP exam. Up what's on your quiz. So you have a quiz on Thursday, and that's going to basically cover homeworks 1, 2, and 3. After the quiz, we are going to look at the different types of word problems we have with differential equations. So your homework is basically, it is from the textbook. I do want you to do 2 through 22 evens. The way the homework is described is it does just ask you to find the particular solution or the general solution. And so for the homework, you do not need to solve for x, or excuse me, for y. That being said, the answer key does have all of them solved for y, and if you look at a problem and you couldn't automatically figure out how to get the y by itself, I am going to tell you to go ahead and try it yourself. I'm trusting that if you've made it this far in BC calculus, you can do simple algebra and solve for y. But if after integrating you look at that and you're like, I have no idea how to get y by itself, then go ahead and try it, because probably on your quiz and your test and AP exam is you are going to have to solve for the y. That would be just kind of like up to you if you need to do all that extra stuff. Tomorrow we just have that one example to finish, plus like some log and exponent rules that often show up in these problems. And then Wednesday, that shortened period is going to be a work day, and then you're going to have a quiz on differential equations on Thursday. And then after the quiz, we have 2 types of work problems we have to cover. We have to cover the proportionality problems and then the logistic growth problems, and then we'll run into our test. And then that will bring us to about the middle of March when we finally get to start series, the fun unit. So y'all can go ahead and get started on the homework. Again, you do have a lot more time, I think, in this unit to get stuff done.